Hello class! So it's me again, Engineer John Ray Pacturanan. So this time, ang pag-uusapan naman natin is this example number 12 na nakikita nyo sa screen nyo. So if you want to be updated nga sa aking mga lecture videos, please do not forget to subscribe to my channel and hit the notification button para nga maging updated ka. So this example now is the last example that I am going to present to you related to the application of the moment area method class sa mga simple beams. And ngayon, ang gagawin naman natin ay may overhang nga. So kung maalala nyo class last time, ang sinolve natin ay non-prismatic. Okay? So ngayon na may overhang, sige, paano natin to class isosolve? No, kasi yung solution nito class is different doon sa solution na present natin previously. Pero sige na nga, subukan na nga natin siyang isolve. Basahin ko lang, example number 12. Determine the deflection at the left and right overhang of the beam loaded as shown below. So ito siya. Actually, familiar ito class kasi this problem is example number 6 given in the double integration method. Of course, so since na-solve na natin ito class using DIM, i-compare na lang natin yung magiging final answer natin using the moment area method. So sige, punta na tayo class sa OneNote. Okay? So nandito na tayo sa ating OneNote nga, no? I already pasted the problem and as well as the reactions. Of course, no? If you want to make sure that that the reaction is correct, all you need to do is to pause this video for a while, then solve for the support reactions. Kung maalala nyo class, ito din yung magiging elastic curve ng ating beam ngayon. So, this is quite strange as compared class doon sa ating mga computations, no? So, this is a strange one. So, this time, ang kukumputin natin, since kasi siya, pasad yung ating deflection, so susubukan natin computin yung deflection sa left end and deflection sa right end. So, for the purpose of discussion class, no, although walang point label, itong original problem, I already placed the points as point A, itong left end, tapos yung point B, yung left support, yung point C is yung right end, yung point D is the right support. So, since mga concentrated loads din lang naman to, alam nyong madali naman ang pag-i-sketch ng diagram dito. So, this time, paano natin class, no, magagawa ng moment diagram by part? So, wala naman ngang rule kung paano yun gagawin. Pwede kang mag-fixity sa A, sa B, sa C, or sa D. So, bahala ka na doon, no? Pero ako siguro C. So, trip ko lang ilagay sa C. Sa pagkakataong ito, since concentrated loads kasi class madadali, pwede mo naman ilagay sa A yung fixity. Pwede mo naman ilagay sa B. Wala naman sa inyong nagre-restrict class, no? Pero ako, sa pagkakataong ito, trip ko lang class ilagay sa C. So, this time, since pababa yung 51 class, no? Take note of this, di ba? Pababa itong 51. So, therefore, this must be a negative 1. Okay? So, ang computin natin yan, that will be 51 times, ilan siya? 51 times 5, right? So, 255. So, this will be negative 255. Okay? So, of course, from concentrated load, magiging first degree siya. Might as well, for the 85 kilonewton class na downward, no? I am referring to this one kasi yung 136, malamang wala siyang moment na makikreate. So, 85 times 3 meters. So, coincidentally, naging 255 din siya. So, yun. Gawin na lang natin yan dyan. Gawin na lang natin yan dito. Oops, wait lang. Dapat no, maging straight siya. Wala. Okay na yan. Baguhin ko na lang to class, no? Okay. Ayan. So, sige. Ito din siya. Parehas sila class negative 255. Okay, so okay. Wala naman na kasing upward na concentrated kasi nga, yung mismong reaction class is downward. So, parehas talaga sila negative. So, unfortunately, ito talagang itsura class ng diagram nyo. So, wala naman tayong magagawa. Wala namang sinabi regarding sa wala naman palang sinabi regarding sa flexural rigidity. So, of course, the assumption will be this is a prismatic one. Okay? So, kung prismatic yan, wala na tayong problema. Pwede na natin hanapin class yung deflection at A. So, from the elastic curve, magiging iba yung itsura niya class. So, most likely, ganito yung magiging ating slope, no? Okay? So, ang una kong hahanapin dito class is ito. The deviation of C with respect to the support at B. Okay, no? So, yun yung kailangan natin. At the same time, although maliit siya dito, class, no? Although maliit siya, ito naman, yung deviation ng A with respect sa slope ng B. Kasi yun yung mga kailangan natin. And dito, automatic, this will be the deflection at A mismo. Deflection at A. Okay? So, madali naman to dahil basic lang naman yung mga areas natin. So, yung una is yung EI, deviation of C with respect to the slope at B. So, ang formula niya ay area between B and C lang. Syempre, multiply natin siya class ng centroid with respect sa point B. So, kung titingnan natin tong moment diagram by parts, itong triangle lang na ito class ang i-consider natin. I am expecting the answer class to be negative. Bakit? Kung titingnan nyo, yung point C natin ay nasa baba ni ating tangent line. Okay, no? So, kapag yung point ka ay nasa baba, di ba nga, the deviation must be negative. So, isa yung way para ma-check mo kung tama ang mga pinagagagawa mong solution. So, tunahan na natin for the triangle, that is 1/2. Ang base niya ay 5. Pangit nung pagkasulat ko ng 5, sorry. So, 5. Ang kanyang height ay negative 255. Multiplied natin class ng 2/3 ng 5. Okay? So, that is 2/3 ng 5 kasi most likely dito yung center of gravity niya class, di ba? So, considering kasing point B, yun yung distance niya. Ito class, hindi natin to i-consider. Why? Kasi nga, nasa C dito. Ang usapan, ang i-consider mo lang na area ng moment diagram is from B to C. So, I hope that, that clarifies something in your mind. So, by the way, I forgot to label na step 1 pala siya. So, sige, computein na natin to using, calculator lang naman to. So, 1/2 ng 5, tapos negative 255, tapos 2/3 ng 5. Okay? So, ang sagot natin ay negative 2125. Sige, lagay natin negative 2125. So, next natin na i-consider yung pangalawa class, no, is the deviation of A with respect to the slope at B. Diba? Kasi nga, kung titingnan ulit natin tong diagram, ito siya. Yung deviation ng A with respect to B. So, this will be EI, deviation of A with respect to the slope at B. So, i-consider natin is yung area between A and B multiplied by the centroid at A. Pero, kung titingnan nyo class, yung mismong figure, so tingnan natin siya, walang area sa gitna ni A saka ni B. Oo nga no, wala siyang area. So, ibig sabihin nun class, wala nang compute pa, 0. So, pwede pa lang yung deviation maging 0. Yes, possible yun class that the deviation is 0. But considering the figure itself, it does not mean that the deflection is 0. Yung deviation lang ang naging 0 class. So still, there is a numerical value for the deflection at A. So, pupunta na tayo sa step 3. By the way, ulitin ko kasi baka nagkalito. Paano to naging 0? Simply because there is no area in between A and B. Kung walang area, di tapos ang usapan, 0 yan. Sir, gusto ko tong maging area, ilalagay ko yung fixity sa A. Sige, ilagay mo, pero still, ang mako-compute mo ay 0. Kasi nga, kahit saan mo class ilagay itong fixity natin or itong assume fixed load, dapat pare-parehas ang mako-compute yung mga deviations, no? Walang mababago dapat doon. Anyway, back to the topic tayo. So, for the step 3 naman, ang sunod na concern natin is the part for sketching, for preparation class sa ratio and proportion. Kakaiba kasi itong beam natin, no? Anyway, para masanay tayo sa mga strange na things, no? Ganito na lang, no? So, ito ay hinge, ito ay roller. Check ko lang baka nababaliktad ko yung orientation ng mga support. Yes, hinge and roller siya. So, of course, the elastic curve is located here. Tapos, lagay natin yung mga distances So, this is 2 meters and this is 5 meters, right? Okay? So, yung slope, nandito siya. Nagkataon na wala siyang deviation. Okay? So, ito yung point A. Ito yung point B, ito yung point C, and ito yung point D. So, ilalagay ko dito sa label as EI, deviation of C with respect sa B. So, lagay ko na rin dito, although 0 siya, yung EI, deviation of A with respect sa slope ng B, which is 0 siya. And lastly, itong mas kailangan natin ngayon, yung deflection. Okay? No? So, this is EI deflection at A. So, ito yung ire-ratio and proportion natin, class. Itong maliit na triangle, saka itong malaking triangle. So, still, the ratio and proportion is a critical part of this solution. So, for the step 4, ratio and proportion, so, pwedeng ko na lang ilagay, class, as EI, deflection at A. Supposed to be, sige na lang tuloy, ilagay ko na lang as EI, deviation at A with respect sa B. Pero alam niyo naman nga na 0 na to. But for the purpose of formality, sige na ilagay natin kasi sayang din naman. Divided by 2 is equal to yung EI, deviation ng C with respect sa B, divided by 5. Okay? So, tama ba? Yes. So, gusto ko ditong i-point out, class, no? Ito ang gusto kong tandaan nyo. Kapag nagre-ratio and proportion ka, ang ilalagay mo lang, class, ay absolute value of deviations. Gusto ko yun i-point out, no? Kasi itong mga negative sign for the deviation, it indicates only kung nasa taas ba yung point or nasa baba para masiguro mong tama. But for as long as ratio and proportion is concerned, ang ilalagay ko dito, class, is hindi negative to 125. Huwag mong ilagay, class, yung negative to 125. Ang ilalagay mo dapat ay positive to 125. Kaya nga absolute value. Kasi wala namang pakialam, class, sa sign ang ratio and proportion. Eh, di ba, kung maalala nyo, class, last time, sa mga influence line, di ba, nagre-ratio and proportion tayo para mahanap natin yung mga ordinates. But do we use the negative sign? No, we did not use that. Ang ginamit natin is yung absolute value, tapos titingnan mo na lang yung figure if that is positive or negative depending on its orientation. Gayon din dito. Do not place the negative sign in the deviation. All you need to place is just the absolute value. So, sige na, tama na ng chismisan. So, back to the topic tayo. No? So, ilagay ko lang na EI, deviation of deflection at A. Of course, ito nga na deviation natin, 0 siya. All over 2 is equal to 2125 divided by 5. So, kayang-kaya natin mahanap, class, yung EI, deflection at A, simply equal to 2125 over 5, cross multiplication lang naman to times 2, so 850. Okay? So, lahat nga ng mga sagot natin sa ratio and proportion ay mga positive. So, therefore, ang magiging deflection at A natin, class, ay 850 all over EI. And indicate mo na lang na downward siya. Tama ba? So, yes, this will be the final answer for this part. So, check natin siya using the double integration method. So, from chapter 8, dapat negative 850 siya. So, ito yung beam, class, na sinolve natin. As I said, this is example number 6 considering the double integration method. So, ito yung mga solutions niya. So, wait lang . I think may mali ako. So, pwede yata natin tong i-correct. So, sige nga. Okay. May mali pala ako, class, no? Yung mali ko, itong deviation of C with respect to B. So, dapat ang ilagay natin dito, class, with respect sa centroid sa C. Okay? So, dapat ang maging final answer natin dito ay 1/3 lang ito, class, no? Dapat 1/3. Kasi, kung titingnan nyo, class, from the figure, no, 1/3 siya ng C. I hope that is clear. Okay, so this will be 21, negative 2125 over 2. Anyway, wala naman dito, class, mababago in general as long as naintindihan nyo yung principle, no? So, ino-note ko na lang na yun na nga, dapat pala with respect sa centroid at C. Nalito lang ako doon. So, sige, baguhin ko lang to. Pero still, ang ilalagay nyo pa rin ay absolute value. So, 2125 over 2. So, ang lalabas dito ay 425 lang. Okay, 425. And therefore, pagdating naman dito, class, this will be 425. So, I hope that is clear. No, hindi ko na kasi to, class, uulitin pa dahil masyadong mahirap mag-edit ngayon. So, 425 over EI downward. Chinek ko siya, class, using the double integration method. And ito siya, the deflection at A is negative 425 over EI. So, tama itong process natin. So, next tayo, yung deflection naman sa right support. Ulitin ko, hindi natin concern dito yung maximum deflection kasi nga, more on pang double integration, class, yung mga ganong tanungan. Okay? So, next tayo, i-consider natin yung deflection at the right end, no? Yung point C. Sige, wait lang. So for letter B naman tayo, lagay natin to. Ang tinatanong is the deflection at the right end. Sa case natin, that is deflection at D. So balikan natin yan dito, class. Ito na siya. So mababago yung analysis natin ngayon dito, class, kasi if you are going to observe naman, alagay natin siya dito, no? So itong buong length is the deviation of point D with respect to point P. Ito siya, class. However, ang concern natin is itong deflection at D. So, instead of addition, ang ire-ratio and proportion natin, class, ay subtraction na, hindi addition, subtraction dito. Kasi itong specific length na to ay magiging deviation of D with respect to B minus deflection at D. So, of course, mavivisualize mo nga siya using the diagram for the elastic curve, no, para mas madali siya. So, ang concern natin, dalawang deviation ulit, deviation of C with respect sa B and the deviation of D with respect sa B. Pero yung una, class, na-compute na natin na mali nga ako. So, for step 1, the EI, deviation of C with respect sa B is equal to negative 2125 over 2, which is expected nga kasi nga nasa baba siya. Ganon din dito, class, no? Yung point din natin ay nasa baba ng slope, so you should expect that the deviation is negative 1, or sorry, a negative value. So of course, computein natin siya for the step 2 of the process. That will be EI deviation of D with respect sa B. So that is equal to yung area ng B to D multiply natin ng centroid at D. Okay? So, this time, hindi na ako nagkamali. Okay? So, dito, puntahan natin, itong dalawang triangles na, class, ang i-consider natin. But the centroids must be respected sa point D. So, unahin ko na, magiging 1/2 ng 5 meter, tapos negative 255. Tama ba? Yung height ng triangle ay negative 255, and its center of gravity is 3 meters plus 1/3 ng 3. Okay? So, times 3 plus 1/3, sorry, ng 5 meters. So, yun yung mangyayari. On the other hand, another 1/2 ng 3, negative 255. Multiplied natin siya ngayon, class, ng simply 2/3 lang to ng 3. Tama ba na 2/3 ng 3 siya? Yes, kasi nga, kung mangyayari dito, this is 1/3 of 3 and this will be 2/3 ng D. Kasi nga, with respect sa point D ang kailangan natin. So, if we calculate for this one, magiging 1/5, 1/2, sorry. 1/2 ng 5, negative 255. Tapos, 3 plus 1/3 ng 5. On the other hand, plus 1/2 ng 3. Tapos, negative 255. 2/3 ng 3. Ang final answer natin dito ay negative 3740. Ayan na siya, class. So, therefore, since meron ka ng values nitong unang dalawa, ang mangyayari, step 3 na lang tayo. No? Ang step 3 is, of course, the sketching for the purpose of ratio and proportion nga na mangyayari sa step 4. So, ito yung ating beam. Lagay natin yung mga supports. Tapos, draw ka lang ng qualitative elastic curve. Ayan siya. And of course, ito yung ating slope. So, therefore, this will be EI, deviation of C with respect to B. I forgot to place the points, no? A, B, C, and D. On the other hand, no, the distances as well, 5 meters dito. So, 2 meters pala, 5 meters, and 3 meters. Might as well, automatic nga ito, yung ating EI, deviation ng D with respect sa bito. Ang concern natin is itong deflection, EI deflection at D. So, therefore, ang magiging tawag natin dito is ito na siya, EI, deviation ng D with respect to B, minus EI, deflection ng B. Ito, class, yung kasama sa ratio and proportion. 'Di ba? Kasi ito yung mafo-form na triangle. So, I hope that is clear. So, for the step 4, ratio and proportion, pero ulitin ko, ang gagamitin natin ay absolute values lang naman dito. So, substitute natin siya ngayon. So, una, EI, deviation of C with respect to B, yung mas maliit, over 5, is equal to EI, deviation of D with respect to B, minus EI, deflection at D, all over 8 meters. I hope nagagets nyo itong ratio and proportion ko, di ba? EI deviation at C with respect to B is to 5, tapos EI deviation at D with respect to B, minus EI deflection at D. Nagkamali lang ako, class, ng pagkasulat. So, deflection at D is to 8 meters. So, substitute mo lang yung mga absolute values. Kaya magiging 2125 over 2 divided by 5 siya. Tama ba? Yes, 2125 divided by 2 over 5 is equal to, yung deviation natin in absolute value is 3740 minus EI, deflection at D, all over 8. So, using shift solve, pwede mong mahanap yung EI deflection at D. So, computein natin, 2125 over 2 divided by 5. And that is equal to 3740 minus X all over 8. Right? So, if we shift solve this one, 2040 siya. So, pwede natin masabi na yung deflection at D is equal to 2040 over EI. And based sa figure natin, pababa siya, class. Okay? So, ito na yung ating final answer. So, box ko lang siya. Ayan na, class. So, to conclude for this one, lagay na lang natin, class, for summary para ma-finalize na natin to. So, yung deflection at A is equal to 425 over EI, the downward. And yung deflection sa B is 2040 over EI, downward din. Okay? So, I hope that is clear. Ito na yung ating final sagot o final answer nga. I-check natin siya, class, sa double integration method. So, kung ito yung deflection sa A, kasi nga, I am using the same orientation of points nga. Okay? Pasensya na naglo-loading. Ito siya, class. So, yung left end ko, I label it at A, and yung right end ko nga, I label it at D. So, parehas DIM. If you observe this, the deflection at D is negative 20, 40 over EI. Of course, if you recall for this video nga, ang hinahanap talaga dito is yung ating maximum deflection. But still, from double integration, napatunayan natin na tama yung process natin kasi nga parehas yung mga na-compute natin. So, I hope, no, wala na ditong masyadong malilito sa topic natin for the moment area theorem sa mga simple beams. So, thank you so much for listening to me and I hope nga may natutunan kayo sa akin. So, our last discussion for this playlist will be played na after nito. Ang pag-uusapan na natin is another method, the conjugate beam method. So, bye-bye, class. Ingat kayo.